Of derivative. So, as you might have guys studied in the previous classes, what derivation and derivatives look like. So, you might be aware what are the application it has. So, some of the applications that we'll try to cover is derivative as a rate of change. So, as you might like, let's start with basics first. So, as you might be aware, what derivative looks like. So, derivative is simply a rate of change, right? What we define as a derivative f dash of x is a limit where del of x is going to 0 with f of x plus del of x minus f of x upon del of x. And that can also be equivalent of del of y upon del of x. That is a rate of change of x of y with respect to rate of change of x, right? So the first thing that application of the derivative we see is in rate of changes. Then what do we have like in the further lecture is the angle of intersection of two curves, increasing and decreasing curves, example, like further things. So let's first see that what all we are going to cover. So again, talking about rate of change of quantities. So what do we have here is y is equals to f of x as our function, and dy by dx represent the rate of change of y with respect to x. Yeah, as we stated that earlier, right? So again, this is the change, the time. Okay, so sorry, just a minute. Yeah, so this is very simple. So this what we did in the previous class, that we did this the parameter differentiation, right? That if we differentiate the function of y with respect to t and differentiate the function of x with respect to t and take a division of both of these, so what we get is the rate of change of y with respect to rate of change of x, because dt and dt would get cancelled out, right? That is why this is what a rate of change is defined as. So rate of change is defined as dy by dx. Guys, that y increases and x increases. If that decreases and x, understandable that if one of the quantity, if both, see, dy by dx is positive, so that means that both of these terms are positive, or both either of those, then that positive change would also be reflected in the other partner. But if if it is negative, then the inverse would be true, as the note states. So find the rate of change of the area of the circle with respect to its radius when r is equals to 3 and r is equals to 4. So it is very easy. What do we do here is what is the area of a circle look like? Area of a circle is defined as pi r square, and we have to find the rate of change with respect to its radius. So what do we do is dA by dr. And what do we have here is 2 pi r. So the rate of change at r is equals to 3 would be 6 pi. At 4, it would be 8 pi. Marginal cost. Okay. Marginal cost represents the instantaneous rate of change of the total cost at any level of output. If C of x represents the cost function of x units produced, then marginal cost MC is given by, okay, this has been already given to us. And marginal revenue represents the rate of change in total revenue with respect to number of items sold in an instant. So also, this is also something important. So if R of x is the revenue, this is something like then try to explain how the derivation can be used in marginal cost and marginal revenue. Okay, so total cost Cx in rupees associated with the production of x units of an item is given by this. Find the marginal cost when 18 units are sold. So again, if marginal cost has to be found out, so we can differentiate C with respect to X and get the what they have done in the example itself. Okay, so C, it's a direct example, and you can see what the application of derivation look like? Now, moving on to the next question or the next concept, what do we have is increasing and decreasing functions. So let I be an open interval contained in the domain of real valued function f. So then the function is said to be okay. So increasing on I if x1 is less than x2 in I and f of x1 is less than f of x2. Okay, so this is very simple and understandable that if the value of x is increasing in an interval, if we move towards the right, the function value should also increase, like this kind of a function, this kind of a function, this kind of a function. So what are these functions? For a first that comes is e to the power x. This is an increasing function. Log of x is also an increasing function, right? Now strictly increasing, then the equality would get out. What do we mean by strictly increasing? That f of x of 2 would increase always. So this is another thing that we have discussed. Now, what do we mean by decreasing? Decreasing means the accurately opposite of it. That if x is increasing in an interval, the function has to reduce. So we'll reduce this. We'll reduce this to the strictly decreasing as well. That if x of 1 is less than x of 2, and if f of x1 is has to be always greater than f of x2, then the function is strictly decreasing. Okay, so now let's move on to another function. Okay, so this is another way of seeing the decreasing and increasing part of it, where we use the differentiation, right? So as we are discussing the application of derivatives, increasing and finding out if a function is increasing or decreasing can be easily done with derivatives. So if a derivative of f(x) is positive for each of x in a and b, the function is increasing. If it is negative, then the function is decreasing. How do we say that? See, f dash of x is the slope of the function. And if the slope is always positive, that means the curve is always moving in an upward direction, right? Then we can say that f of x is always increasing. Okay, the first derivative test. I think we can spend some time more on the decreasing and increasing function because it is something important for. And by decreasing, what we mean is if this is always decreasing, right, right, it goes to in a downward direction. So if the slope is decreasing, then the function is always decreasing its value, right? That is why we say that if the derivative is negative, then the slope is negative, and that implies that the function is always decreasing. Now let's move to the first derivative test. So what does the first derivative test say here? Let f be a function defined on an open interval I. Suppose SEL is any point. If f has a local minima or local maxima at x is equals to c, then either f dash c is equals to 0 or f is not differentiable at c. Okay. So this is understandable. We'll discuss this in more detail in the further. So what is a critical point first? So a point C in the domain of function f at which either f dash c is 0 or is not differentiable is the critical point of f. Okay. So let f be a function defined in an open interval I and f be continuous on a critical point C in I, then if fc changes its sign from positive to negative as x increases through C and then decreases, then it's a local maxima. Okay. If f dash x changes its sign from negative to positive, so let's see what do we mean by this first point. If f of x is changing from negative, so this was negative and then positive. So this point becomes a point of local minima. If it was changes its sign from negative, huh? Okay, yeah, from negative to positive, so then it is minima. It is if it is going from positive and then going to negative, it is the point of maxima. See, another thing that we did, point of inflection, that if it does not change its sign and if it increases through C and keeps on increasing, so and it changes its signs as well, right? So it becomes a point of inflection. Okay. So let's talk about approximation. Approximation is also an important application of derivatives. That how do we approximate, right? Let's see how is that done using derivatives. So what is given to us that let y be a function of x and del x be a small change in x and del y be the corresponding change in y. So again, we know the definition, what del y looks like and what dy looks like. So let's take an example and try to solve this equation. So what is given to us that we have to find the root of 25.3. So let's consider y is equals to del x. So x is 25 and sorry, y is equals to root x. So x is at 25 and del x is 0.3. So del y is equals to root of x plus del x minus root x. So this is what we have as our equation, right? So now we are calculating del y here. So del y is equals to dy by dx into del x. So that is what our value is. I hope you guys understood here. So what the catch here was, we have defined del y into dy by del x approximately as dy by dx. We have taken this as the approximation and that is why we are moving forward with the question. So let's do this question. So we have x is equals to 2 and del x is equals to 0.01. So f of x, we know what has it become. This is what we have. Okay, you can see like, okay, I was reading the solution. So this is very similar to what we did in the last question. So first we define what are x's and what are del x's. Then we take find the value of this, right? So this is what we have. Then we have to find what delta x looks like. So I think we have done something different here. So the thing what they're trying to do here is they're introducing del of x here. So how is that coming about? There was no del of x introduced here. No, it was. Okay. So what we are doing here is we know, okay, I get it. So this we know, right? So what they're trying to substitute this as f dash of x into del of x. So this is the thing it converges to. So this we have written here, let's take all the red marks here and write it again. So this becomes this, right? This becomes f dash of x into del x. And we are left with this. The slope of a tangent to the curve y is equals to fx of point x1 y1 is given by. Okay. So this is what we have the tangent. See, again, we discussed the tangent points thoroughly, right, in our previous classes that the derivative is what is is exactly what a tangent is. So I don't think we have to discuss what a tangent look like. We know that a derivative of a point, a derivative of the function at that point is the tangent. And the slope. See, there's a, of course, if let's see, if this is the graph and this is the, sorry, this is the graph, and if this is the tangent, so the normal would look like this. And we know that two lines that are subtending 90 degrees to each other are perpendicular, and the product of their slopes is -1. So the slope of the normal to the curve becomes like this. Okay. So the equations of tangent and normal. So the equation of tangent of the curve is given by this. Okay. Fine. The normal looks like this. Again, it is very easy to understand. This is also something not out of the box. What it is trying to say that if the slope of the line of the tangent line is 0, then what it means is the tangent is parallel to x-axis and the normal would be parallel to the y-axis. As simple as that. Okay. So now moving on. So let's do this. Parallel to x-axis tangent, that means dy by dx is equals to 0. As simple as that. So 3x square minus 6x minus 9 is equal to 0. X square minus 2x minus 3 is equal to 0. X square minus 3 plus x minus 3 is equal to 0. X minus 3, x plus 1 is equal to 0, 3, and minus 1. Right? Okay. So the next application that we have of derivatives. See, again, we can check out tangents and normal thoroughly. Also, if you guys might have done conics for JEE preparation, you might have applied differentiation, integration, not differentiation, but not integration, but differentiation a lot in conics, because a lot of equations are easily solved, like to find the normal to the tangent or anything, something like that. You require differentiation to a very large extent there. So the application to the conics of differentiation is to a very large extent. So I hope you might be using those formulas there to calculate the normal or the tangent. So now let's move to the maxima minima part. So of course, if you guys have not seen the videos earlier, so what do we mean by the maxima and the minima? So there are two types of so let's okay. So maxima first we can see is a point that has the maximum value in the graph. It is a very like layman definition of a maxima. And similarly for minima, that the minimum value of the function is the minima. Okay. So now, but now there are subparts to it. That maxima can be of two types. That is a local maxima and the universal maxima. The global maxima or the local maxima. So the local maxima is if there is a graph that looks like this, looks somewhat like this. So, so this is the local maxima, but this is the global maxima because this has the highest value all over. But this has not has the highest value all over, right? But it has higher values than its neighboring value for a larger extent. That is why it is the local maxima and that is the global maxima. Similarly for global minima and local minima. Okay, so let's not go to the theory part of the local maxima and minima because there is very direct way of solving a maxima and minima. So what we do here is we do the second derivative test. This this is very important while calculating maxima and minima. And using this, you can easily solve a lot number of questions here. So what we do here is that if fx is a function defined in an interval I and c is a part of I, let f be twice differentiable to c. Okay. So first condition of this test is that f has to be differentiable, twice differentiable at the point c. If it is not differentiable, then we cannot find the maxima and minima easily. So the first thing that we have is first condition. Let's use a highlighter here. The first condition that we have here is that if x at x is equal to 0 is the point of local maxima if the single derivative is 0 and double derivative is less than 0. And for this, if we have x is equals to c is the local point of minima if f dash of c is 0 and f double dash of c is greater than 0. See, it is very easy to remember that for maxima, f double dash has to be minimum, like 0, less than 0. And for minima, f dash of 0 of that point has to be greater than 0. Like, bear with my handwriting, guys. I hope you're able to understand what I'm speaking. So let's go with that and what has been stated here. So now moving on. Okay. So let's do some questions here. So what is asked us to do? Find two positive numbers whose sum is 6 and whose sum of cubes is minimum. Okay. So what we have here is x plus y is equal to 16 and we have to minimize the sum minimum. So what we can do here is x cube plus y cube. So it is 16 minus x cube. And we have to minimize this. So we'll minimize this with respect to x. Let's minimize this. So 3x square plus 3 of 16 minus x whole square minus 1 is equal to 0. Because the first derivative has to be 0, right? To 0. And we'll neglect the 3 and we have x square is equal to 16 minus x whole square, x square minus 16 minus x whole square is equal to 0, x minus 16 plus x into x plus 16 minus x is equal to 0. So here x and x get cancelled, 16 goes to 0. We have 16 minus 12 is 8. We have a value of 8. So we'll check. So first of all, first green check or first green tick for us here is the quadratic should have given us two values, but since it gave us one value, it has to be the minimum. It cannot be the maximum, but then too we'll check it through and we'll check the derivative. So let's calculate the second derivative here. The second derivative here becomes 2x plus 2 times of 16 minus x with a negative sign, and then negative gets cancelled. This becomes 0, and at 8, this becomes positive. So if the double derivative is positive, then as I told you, with double derivative being positive, it is the minima at that point. So again, we have our answer here. Okay, the next question. So the absolute minimum value, let f of x be the function defined in its domain z belongs to R, and then f of x is said to have the minimum value at a point at A belonging to Z. If f of x is greater than f of A, then okay, I'm not getting this part, guys. This is something very theoretical, I suppose. You can give it a read through, but JEE-Main does not focus that a lot on theory. This can be like help you in your JEE advance, I suppose. So I think you can read these through for that. Let's do some PYQs if possible. Okay. So the first question that we have here is that we have a function f of x that is e to the power 2x minus 1 upon e to the power 2x plus 1. And we have to find either the function is increasing or decreasing. It's very easy. Let's subtract and add plus minus 2 here. And what are we left with is if we add plus 2 and minus 2, so we'll left with 1 minus 2, right? Now let's differentiate. So it is 1 minus to the power ex 2x plus 1 to the power minus 1. 0 minus 2 as it is, minus 1 e to the power minus 2x plus 1 to the power minus 2, whatever with the pen. And then we have e to the power 2x and a 2 again. So we have 4 e to the power 2x plus 1 to the power minus 2 into e to the power 2x. So since this is a positive term, this is a positive term, it is always increasing. So it is very easy for us. They didn't ask us the odd function. They had an option of even, but we checked for decreasing and increasing and we got the answer. So let's move on. So the next question we have here is if f of x is equals to 2x cube minus 3x square plus 12x plus 5 belongs to minus 2 comma 4. Then the maximum value of the function is in the following value. Okay. Okay, so first we'll check if it's an increasing or decreasing function in the interval provided. So let's see that first. So let's see if x square plus 6x, sorry, it's a minus sign. Let's write properly, guys. So we have 6x square minus 6x minus 12 is equal to 0. X square minus 2x plus x minus 2 is equal to 0. X minus 2, x plus 1 is equal to 0, 2 comma minus 1, right? So the derivative of this function has at a level minus 1 and 2, and it is a positive, so it goes like this. So see, from minus 2 to 4, minus 2 to 4, the function is decreasing also, and is first is positive, is negative, then positive. Then we have to find the maximum value. Where does the maximum belong? Okay, so let's check. So what we can do here is the function is decreasing from minus 2 to this point. This what is this point? This point is zero point 0.5. Minus 2, 2 minus 1 is 1. 1 divided by 2 is 0.5. So this is 0.5, right? So at 0.5, the graph would have an inflection point because let's calculate the double. No, let's not get that complicated. F dash x is 0 at these 2 points, right? So it is a cubic graph, right? So it would look something like this. And this is at minus 1, this is at plus 2, right? So the maximum that we can observe it as at minus 1 or at 4. So let's calculate. At minus 1, what is the value? At minus 1, we have minus 2, minus 3, plus 12, plus 5. It is 17 minus 5, that is 12. Do we have a D option? No. Oh, I'm in trouble then. The maximum is, then it's 4. Why not? Yes. Oh, they have done a shitty thing. They just simply put the values and found out their answer. It is not the way, guys. You should not do this. You can try some derivative part of it and you could draw the graph and get some answers out. Let's do some other question. This spoiled the flow of our action. So let's do some other question. Correct. We are not promoting anything, guys. We did this, right? We did this as well. Why is it not moving? Okay, let's do this one. The ratio of the height of the cone of the maximum value inscribed in a sphere to its radius. Okay, we have a we have a sphere and we have a cone here. I'm in a sphere, so we have a cone inside, and the volume is maximum. But why have they taken R here? So okay. So what they have done is, there is a problem in this question. So what they have done is, they have taken the radius of the cone and the radius of the sphere as same. If you check here, they have simply replaced x by 2r. That should not be the case, right? Or that should be the case. I'm not aware. Okay. So if what they have done here, okay, they have written x square is equals to y into 2r minus y. And how did they land about it? I am not sure. This and this. So this cos square is equals, this is equals to y. Okay, okay. No, I'm not sure. Let's skip this question. I'll try to provide a solution to you of this in the upcoming classes. Let's do this one. So we have AB is equals to 2A plus 3B. And the minimum value of AB is, wow. So let's calculate the minimum of it. So how we can proceed about this is, let's let's do one thing. Let's take them to one side. So A common B minus 2 is equal to 3B. A becomes 3B upon B minus 2. Then BA, okay. Now we multiply a B here. So AB becomes 3B square upon B minus 2. Now we have to find the minimum of this, right? So let's differentiate with respect to B. So this becomes our T. We take this as B T, and it is a complete function of B. So dt by dt becomes B minus 2. It's a lengthy problem, so I'll require my space. I'll just do something. Let this be T. So we have B minus 2 into 3B square minus, no, that is something wrong again. 6B minus 3B square upon B minus 3 whole square equals to 0. So this goes to 0. And now let me raise and do it again. Okay, so we have here is B minus 2 into 3B is equals to, it is a 6B, sorry guys, it is 6B is equals to 3B square. So B and B cancel. One solution is B is equals to 0. Then 3 and 2 cancel. We have 2B square minus 4B is equals to B. And that becomes, array, there is a problem. No. So this becomes 2B minus 4 is equal to B. Then it becomes B is equals to 4. So there are two solutions, 0 and 4. So let's put the value and find out. So what was the AB? Array, we have to calculate it again. So A would be B minus 2, B, and A would be, this is what we have, and it is 0. So 0 would give me 0. Let's take 4. So 3, 4 square upon 4 minus 2. So this is the identity, guys, that you must remember that if f of x plus y is equals to f of x into f of y, so it f of x is k to the power x. It is very simple and you can prove it very easily. If f of x plus y, so it is k x plus y is equals to f of x into this. Don't go by my words, but the words that I'm writing are correct. So this is what it means. And it's an identity that you can easily learn. So what we have been given f of 5 is equals to 2. So our f of x is k to the power x. So k to the power 5 is 2. Okay. And so k becomes 2 to the power 1 by 5. And now f dash x, we have to, f dash of 0, we have to calculate. So it is k to the power x as it is and log k. So at 0 is 3. So x is 0. So this is 1. So 3 is equals to log k. Between different vibes here. What is the issue? Let me just wait for a minute. I don't know. There is something wrong here. We know the value of k, right? Then what is the problem? I think there is a problem in this question as well. I'll look up it and tell you. So again, there is a problem of approaching a solution, I suppose. They have approached it with the way of doing limits. So they have written f dash of 5 as f of f plus h minus f of 5 upon h, and then they have tried to use identity. Then we have f of 5 value as 2, then they have taken out 2 as common, and this is at 0. So this is something, of course, this is not, I'm not saying it is incorrect, but the way I was going through was also not wrong. So let's see what is the issue. I'll try to Google it up and show you. We can do this one, it's not that tough. So at x is equal to 0, we get that. We differentiate both the sides. Okay. So it's very easy. It's nothing out of the box. Let's do some another question. Is if y square is equal to px in a polynomial of is a polynomial of degree 3, then we have to find 2 of d by dx y cube. Okay. This is also comparatively easy. What we can do here is do this one. This one is seems a bit easier and done. At what points of the curve the tangent makes equal angle with the axis? Okay. So the equal angle we have it as y is equals to 45, y is equals to minus 45. And that the slope is plus minus 1. So we define the derivative. Yeah, the derivative is calculated. It's very easy. What was the point here? Fine, let's do some other question. It was very easy. Check the function is increasing or decreasing. Wow. So let's do this. Okay, so this is also very easy that differentiated and tried to see that if it is positive or negative. That can be easily understood and solved. Let's move on to another part of it. If you want to recap any theory, guys, you can also like put in the comments. I'll try to answer it. Okay, so another question that we can do here is this one. Yeah, this one. This let's try to do it by ourselves. So I think we let's see how we approach it. So let me take some space here. So the question that is given to us is y is equals to 2 by 3 x cubed plus 1 by 2 x square. And we have to find when the tangent makes equal angle. So dy by dx should be equals to 1 and minus 1. So let's calculate it. Let's calculate dy by dx. So dy by dx is 2x square plus x. This should be equal to 1. So x, 2x plus 1 equals to 1. No. So 2x square plus x plus minus 1 is equal to 0. So 2x square plus 2x minus x minus 1 is equal to 0. 2x common, x plus 1 minus 1 common, x plus 1. We have minus 1 and 1 by 2 as our roots. So let's check. So we have two tangents here, right? Let's see. Okay. So there are 4 points. Why would you have neglected the minus 1? I don't know. Acha. Okay. They've simply used 2 points. So, okay, that's very easy. But these make equal angle with the axis, right? So these are the two tangents that these 2 points are the tangents from which the tan sorry. So these are the 2 points from which the tangent extends 45-degree angle. They have not considered the negative sign here. We could have also considered the negative sign and getting out a different type of tangents, but okay, that's also an absolution. Now moving on. This question we already said that it was easy and can be easily done. So let's move to a different part. Okay, so let's see. Rolle's theorem. Let's discuss what Rolle's theorem is. So what does Rolle's theorem says? Rolle's theorem says that if this is the graph and if the Rolle's theorem is applicable at this interval and this interval, that means that this at these two intervals, the function's values are same. See, we can see here it is stated in the solution as well that since Rolle's theorem is applicable here for x is equal to 0 to 1, then f of 1 would be equal to f of 0. And it is where the slope can be equal to 0 because if a graph is going like this and has two same values here, so they have okay. So this is what we have. So quite applications. Now let's see another question. The question here is the distance traveled s by the particle t in t seconds is given by this. What is the speed of the particle after 1 second? It's very easy. We'll do ds by dt. We have 3d square plus 4t plus 1, and at 1 we have it as 8. As simple as that. Do we have more questions with us? Let me check once. We have a few more questions, I suppose. Yes, we have few more questions. So let's see that if g of x is a curve which is obtained by the reflection of this about y is equals to x, then okay. So see, this is very nice. This, what does this mean? That it is inverse of f. So let's calculate the inverse of f, and this is the inverse of f that we get. So what do we do here is, if y is equal to e to the power x minus e to the power minus x upon 2, so let's change them up. It becomes x is equal to e to the power y minus e to the power minus y upon 2. So it is 2x and e to the power y minus 1 by e to the power y. Now what we do is, we take, what do we do? No, no. How do we do this? I'm forgetting the method here. Just a minute, give me guys. So what can be done here is, okay. So we take e to the power y is equals to t. So what we have is e to the 2x is equals to t minus 1 by t plus 2 minus 2. But that is not necessary here. So it gives me 2x is equals to t minus 1 by t. So it is t square minus 1 is equals to 2xt, and that is tx square minus 2xt minus 1 is equal to 0. So t becomes 2x plus minus root over 4x square minus, it is 2ab, right? So it is plus 2 upon 2. So e to the power y becomes this, and let's take a log of this. So log of 2x, yeah, yeah, this is the function that we obtain. And it should be 4 here. So this gets cancelled, and we have x plus root of 1 plus root of 1x square. This is how we calculated this. If many of you guys might have not understood how we did that. So we just change their variables to this and calculate it y in terms of x. Okay. So now we calculate g dash of x and see that when the tangent is parallel or not. Let's do some another question. This is an interesting question. We can do this question. The tangent of the curve y is equal to x drawn at a point c comma e to the power c intersects the line joining the points this and this. Okay, so fine. Let's let's find what the tangent is. So to the tangent dy by dx is equals to e to the power x only. So the equation of the line becomes e to the power cx is equals to e to the power c x minus. This is the tangent, and the line moving through these points is uh, let's draw it now. It's very easy. If this is the point, let's say, so this is the tangent, this is the tangent. Oh, sorry. Okay, fine. So this is another. Yeah, it's very easy. I'll show you the solution of it. It's very easy. Let's go through the graph. This is the point. If this is C, this is C minus 1, this is C plus 1, right? So this is the line, and this is the tangent. This is, and this is the tangent. So as we can see that as the slope of this equation, what is the slope of this equation? E to the power c plus 1 minus e to the power c minus 1 upon c plus 1 minus c minus 1. So we have c, let's see, take common. So we have e minus 1 by e by 2. So let's check if this is positive or negative. So e minus 1 by e by 2. So if this is positive, Let me check. E is 2.71. So 1 by 2.71 would give me something less than 5.5. So this is greater than 1. So the slope becomes positive and it has a more increasing curve, right? So this is more like this and this is like this. So it is on the left A. Yeah, so we checked out what the slope look like. Next question, what we can do here is, let's do this one. This is a bit nice one. Just a minute. Yes. So what we have here is this. It's solved by myself. F of x is equals to sine square x to the power minus 2 sine square x. So we can write d is equals to sine square x. Okay, fine. That is done. So we have a new function f of x as g of t. Okay. Then g dash of t becomes this. Okay. This is also done. It was very easy, guys. Come on. Let's do something more. Okay, so very easy. The y here becomes minus 1 by 2 of x. So slope is minus 1 by 2, if I'm not wrong. And here, what the slope looks like, dy by dx is equals to minus sine of x plus y into 1 plus dy by dx. So let's calculate dy by dx together. Just a minute. 1 plus sine of x plus y minus sine of x plus y. So dy by dx becomes minus sine of x plus y upon 1 plus sine of x plus y, right? And this should be equal to minus half. So let's cancel half and half. And what we get is 2 sine of x plus y should be equal to 1 plus sine of x plus y. So it should give me sine of x plus y should be equal to 1. So that is x is equals to y. Yeah, very easy. That is what we calculated. Okay, this is something easier. I'm not getting the part why we have taken y is equals to 0. There is no condition of it being 0, right? Then, so we'll check it out later on. Let's see. Let's move on to another part. Let's do this one. Which of the following is true for this? So let's check it out. Ln of 1 plus a 1 plus x is greater than x. Okay. So let's differentiate it. 1 minus 2x by 2. So it is 1 by x, 1 minus x, and its the differentiation is 1 plus x. So this and this is negative, this it's decreasing. So at 0 it is 1, then it is decreasing to infinity. This at 0 is 1. This is not decreasing because it is positive graph, so it is increasing. So it is true. Let's check out this. It is 1 plus, for here it is 1 upon 1 plus x, the slope, and here the slope is 1 minus this is right, and this ka differentiation. So it is minus 2 uh, x to the power a whole square. So it is an increasing graph. This is comparatively increasing at a faster rate, so it has a more positive value. No, B is correct. B is correct, right? B is correct. Yes, yes. So I think with this question we can end our session here. Uh, we have ended the session, so could you just stop the recording? We have done this solution.